Okay, welcome. We're going to look at graphing today for part 2. We ended up with example 6 on part 1, so now we're going to talk about part 2. Probably should get off that there. Okay, so we're going to look at graphs of rational functions. So to do that, we're going to find and plot a y-intercept by evaluating f of 0. We're just going to plug 0 in for x, and then we're going to plot as coordinates. We're going to find the zeros by setting the numerator equal to 0 and then solving for x, and then we'll plot those. Then we'll find the zeros of the denominator, because that's where our domain comes into play, or our vertical asymptotes, and we'll sketch those. Then we'll find the horizontal asymptote and sketch it. And then it says vertical asymptotes divide a graph into sections. So sometimes the horizontal asymptote will apply and other times it won't. And then we're going to plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. And then we have to use smooth curves to complete the graph. So we're going to sketch the graph of 8 minus 3x over negative 2 plus x. So the first thing we're going to do is we're going to find the zero, or the y-intercept, by plugging x at 0 in for x. So we're going to end up with 8 minus 3 times 0 over negative 2 plus 0. And that will equal negative 4. So 0, negative 4 is our y-intercept. Then we're going to take the numerator and set it equal to 0, and we get minus 8 divided by negative 3, we get 8/3. So the zeros always come from the numerator, we know that. So then we have our y-intercept and our x-intercept. Okay? Now then, the next thing are vertical asymptotes. So our vertical asymptotes are simply going to be leading term over leading term, which in this case, I believe is going to be, set the denominator equal to 0. It's x equal 2, right? So that's also where our domain is not exist at 2, because x cannot be 2. So x can't be 2, so therefore x is 2 is our vertical asymptote. Now I know that our y-intercept was 0, negative 4, which is right there. And our x-intercept is 8/3 0, which is 2 1/3 0. So that's what we got so far, and I know you could see the graph. Now, how do we find the horizontal asymptote? We're going to take negative 3x over x, leading term over leading term. Which are those two? The leading coefficient of each, the x's cancel, you get negative 3. So at negative 3, we're going to have an asymptote, a horizontal asymptote. So now your additional points, you can plug in, say negative 2, negative 4 into that equation, and you can plug in 3 and 4 to that equation. But we can tell that it's going to be one of these Nike symbols to the right and to the left. And I know I should have done this by hand, but I wanted to show it a clear vision of it, a clear version of it. So that is what it would look like, okay? Now what is the ending behavior? Well, what's y approach as x approaches in negative infinity? Negative 3. So y approaches negative 3 as x approaches negative infinity. And it also approaches negative 3 as x approaches positive infinity, doesn't it? So it's going to be plus or minus infinity. Y approaches negative 3. That's the end behavior, both to the left and to the right. Now the domain is negative infinity to 2, union 2 to infinity. And the range is negative infinity to negative 3, union negative 3 to infinity, because it just does not get to negative 3, because we have a horizontal asymptote there. And that's how we do how we graph rational functions. All right, now I'm going to try to do this one without giving it away. I know we've already given it away, but that's okay. The y-intercept then would be, you plug in 0, you get negative 4 over 0. Well, that means that can't be. The x-intercepts, we set the numerator equal to 0, so it's 4, 0. Okay, what else were we supposed to find? The vertical and horizontal asymptotes. Okay, so the vertical asymptotes are found by finding the denominator, setting it equal to 0. We're going to factor out an x. Looks to me like x can't be 0 and x can't be 3. So our vertical asymptotes then are x equals 0 and x equals 3. Okay, so we have two vertical asymptotes. Horizontal asymptotes. We take leading term over leading term, which is x over x squared, which gives me 1 over x. If you recall, that gives me one of these burgers, and that means it's going to approach 0 in both directions. So y equals 0 is our horizontal asymptote. And let's see, our domain is negative infinity to 0, union 0 to 3, union 3 to infinity. That's up here. That comes directly from the vertical asymptote. What's the range? Well, that's going to come from the horizontal asymptote, negative infinity to 0, union 0 to infinity. Now let's see what this thing looks like. As best we can, that is. Okay, so we know that we have a x-intercept at 4, 0. We don't have a y-intercept. We know at 0 and 3 we have vertical asymptotes. 0 and 3. Wonder what's going on here. We have a horizontal asymptote at 0, so I'm betting it crosses in the middle here. Boy, this is going to be interesting. Now we need some additional points, don't we, to find out what's going on. So from the negative side, from negative infinity to 0, we can start plugging in points. If we plug in negative 1, we'd get negative 5 over 1 plus 3. So I believe we'd get, if we plug in negative 1, we get negative 5 over 1 plus 3, 4. Negative 5 fourths, or negative 1.25. Let's plug in 0. What would we get when we get 0? So, or we get undefined, so we can't do that. Negative 2, that'd be negative 6 over 4 plus 6. So negative 3/5. Negative 3 would be negative 7 over 9 plus 9 would be negative 7/18. Okay, so the numbers are getting smaller. So I believe we would be looking at something that looks like this on the left side. Now between 0 and 3, that's going to be interesting. So let's try 1. 1 minus 4 is negative 3. 1 minus 3 is negative 2. So that'd be negative 1.5. Put 2 in there. 2 minus 4 is negative 2 over, can't do this in my head, 4 minus 6, negative 2. So that's 1. So negative 1.5 and 1. Negative 1.5. 2, 1. Oh, I know. I think this is what's going on. But we don't have a 0, do we? Do we have an x-intercept? It's over here. Huh. We might have to cheat and graph this. I'm going to cheat and graph it quick. Divided by x squared minus 3 what's going on in the middle. We got that part right. Whoa, 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 whoa. Did I graph something wrong? Yes, I did. I forgot the 3x. There we go. Yep. So I think our first part was right. Oh, this is supposed to be positive, not negative. There's my problem. So it looks like this. And then we go just a little bit above this and then right back down. So that's what our graph would look like. And we're cheating using graphing calculator. Hey, that's what it looks like right there. Now, what's the ending behavior? We didn't talk about that. So y approaches 0, doesn't it, as x approaches both positive and negative infinity. The domain, I think we already did up above. Now, what's the range? That's pretty dicey. Negative infinity to, where's our y-intercept? 0? Our y, what's our y asymptote? Equals 0. But it crosses 0 up here, I believe, because don't we have a x-intercept? Yeah, it's 4. So we know it goes through 4, so it goes above 0 right here. But man, boy, that's a weird one here. What's going on there? So we probably have to cheat and use our calculator and see if this keeps going up. And we can do that real quickly by just hitting our table and seeing if, as we go beyond, oh, it went up to 1 and then back down. 0.1, sorry. It went a little above 0.1, it went to 1/9, that's 6, and then it's going back down. So there must be a little gap here. Hard to say. I'm going to hold off on the range on that one. That's a doozy. I mean, if I was guessing, it'd be negative infinity to 1 or 0.1, because up on my calculator I got 0.11, and then it goes back down, and then it starts again. It looks like at 1 and goes to infinity. So that's anybody's guess there. Okay, and then on the next one we do the same thing. We're going to sketch the graph and do the exact same ideas. So your y-intercept, you plug 0 in, you get 0 over -3, so it's 0, 0. To get the x-intercept, you set it equal to 0 and solve for x, and you get 0 and 4. But if you look here, what's going to occur? Well, no, that's right. We're good, I think. No, we're not. Yeah, we are. Yeah, we are. And then vertical asymptotes, we'd set the denominator equal to 0 and factor. And once we factor, we get 3 and -1. And there's our vertical asymptotes right there. Our horizontal asymptote is at 3, which is going to lead to our ending behavior being y approaches 3 in both directions, plus or minus infinity, because we're talking about the long run behavior. The domain does not include -1 and 3, so negative infinity to -1, union -1 to 3, and 3 to infinity. And then the range looks like here, we're going to take care of everything, negative infinity